Hello students, let's welcome to our YouTube channel Physics for UG, and in this video we shall discuss about division of wavefront and division of amplitude. So all of you might have studied about what is wavefront. So wavefront basically it is the locus of all the particles vibrating in the same phase, and amplitude is basically the distance from the mean position up to the maximum or minimum height of the particle from the mean position. That is the amplitude. So how we can divide the wavefront and how we can divide the amplitudes and perform various experiments in optics. So first of all, look at here all the experimental arrangements for producing interference involves the production of wavelets which fulfill the requisite conditions stated earlier. Okay, so for interference we need the wavefront condition and the wavefront and the wavelets which fulfill the requisite conditions. These wavelets recombine to give interference patterns, and the wavelets recombine with each other with certain conditions, and they give maxima, they give minima. So various experiments can be classified into two categories. There are many experiments: Young Davosit experiment, single slit experiment, diffraction pattern Newton's ring experiment, Fresnel biprism, Lloyd's mirror, and there are many more optical experiments. And these all the experiments can be categorized into two groups. The first one is division of wavefront. That means how wavefront can be divided. Okay, so when a wave propagates from a source, it creates a wavefront. Suppose for a linear source, for a line source, straight line source, the wavefront is cylindrical. For a point source, the wavefront is spherical, and for an infinite light source, the wavefront is planar. So from this wavefront concept, how wavefront can be divided? So wavelets from different parts of same wavefront are made to travel along different paths only to recombine to give rise to an interference pattern, and the wavelets form the interference pattern. Since wavelets originate from same wavefront, condition of coherent source is satisfied. Since the light from different slits, they have the same source, then the light source must be coherent. So coherent is the most important condition for interference. What is coherent? Coherent means when two light sources have zero phase difference or same phase difference or constant phase difference, then we say that the two waves are coherent. And coherence is the most condition for interference pattern. Now a narrow source, that is a point source or a slit, is required in such cases. Narrow slit is required because whenever a slit is there, suppose two slit is there, then the wavefront, the light will come and the wavefronts are divided in the two slits. In Young's double slit experiment, Fresnel's biprism, Lloyd's mirror belong to this category. In this class of interference, we do not obtain complementary patterns. Look at the figure here. In the first figure, this is the second figure. So in the first figure, this is the source of light S. Which is the source of light S. It produces a light wave. These are the spherical wavefronts. So after some distance, there are two slits. There is the obstacle. There are two slits. One is S1 and the other is S2. The light passes through S1 as well as the light passes through S2. So S1 creates wavefronts and S2 creates wavefront. So these two wavefronts intermix with each other and they create interference pattern on a screen. And this type of distribution of light waves is known as division of wavefront, because the wavefront is divided into two parts. Okay, so next part is division of amplitude. So amplitude of a wave can be divided. How this can be divided? In this class of interference, the amplitude of wavefront gets divided into two parts. The two parts follow different paths and recombine together to produce interference. First of all, when suppose there is a light source moving towards, and initially the light is reflected back from some semi-transparent material, or that is a scratch material. Some light is returned back towards the left, and some light passes through, and there is a suppose mirror, and from that mirror the light is reflected back towards left. So this is the first light reflected, and this is the second light which is reflected, and the two rays after some time interfere with each other, and this type of interference is called division of amplitude. How? A broad or extended source is required in such cases. Interference in thin films and Newton rings belong to this category. In this class of interference, we often complementary patterns. Complementary pattern means both are the patterns complement to each other. Look at the second figure. Here, this is air film, and this is two optical materials. So whenever light comes from A to B, some part is reflected and some part is refracted through the air film, and from that air film it again reflected and it again goes upwards. So first line is the reflected part from the first surface, and second is the refracted part from the bottom surface. So these two parts again interfere with each other. So this is basically the division of amplitudes, because your amplitude is divided, amplitude from this part, from this and this, and divided. Okay, so this is all about division of wavelet, division of amplitudes. Thank you. If you like this video, then subscribe the channel, like the channel, and share the channel. Thank you.